Hello, good day, pre-algebra. We are starting Unit 6 with ratios today. And let's start by defining what do we think of a ratio as, or what do we know a ratio is? Anybody have any thoughts? Aiden?
A number compared to another number.
Very good. A number compared to another number. And in the context of kind of more mathematical terms, what a ratio does is it compares a part to a part. Okay? A ratio compares a part to a part, which is different from a fraction, because what does a fraction compare? A part to a like when we have the fraction 4/5, 4 is our part, 5 is our whole, right? So a fraction compares a part to a whole. A ratio does a little bit something different. It compares a part to a part. Now, earlier, we played a sort of a makeshift basketball game where you got to take and try and get 2 shots into the recycling bin. And our stats, we had makes 8 of them and misses 38 of them. Okay. Woo. So if we were to write the ratio of makes to misses, the ratio of makes to misses would be 8 to 38, right? The number of shots we made compared to the number of shots we missed. It compares a part to a part. How many shots were taken there total? If you made 8, missed 38, how many shots were taken? 46. So the whole is still there, right? We can still identify what the whole is. If we wrote this as a fraction, we would say that we made 8 out of 46 shots. But what a ratio does is it very distinctly defines, if you made 8, how many did you miss? Okay? Boys, quiet. That's once. All right? Those of you that play sports and keep track of your win-loss record, that's a ratio too. It compares the number of games you won to the number of games you lost. You can calculate how many games you played total by adding the two together. Okay, so that's essentially what a ratio does. So we've got a bag containing 6 yellow marbles, 8 blue ones, 3 red ones, and 12 green ones. And what is the ratio of blue to yellow? What is the ratio of blue marbles to yellow marbles? How many blue ones are there? How many yellow ones are there? Leah? 8 to 6. Okay. Does it matter what the order here is? Could I write 6 to 8? Does that change anything? Switching the order? It does. Okay. If it's asking for the ratio blue to yellow, you have to make sure you put the blue marbles first and the yellow marbles second. So 8 to 6. We can simplify these like we can simplify a fraction. Okay. 8 to 6, if we divide each of them by 2, we get the simplified ratio of 4 to 3. Just like if you had the fraction 8/6, you divide each by 2 to get the fraction 4/3. So there is that connection there, but it's a little bit different than a fraction in the sense of what it compares a part to a part. How this is written, you'll most commonly see it as I've been writing it so far with that colon there. Okay. You'll also see it with the word 2, 4, 2, 3. And less commonly, I'm debating even telling you this because I don't want you to confuse the two, but it is possible for a ratio to also be written in fraction form, which is kind of ridiculous since it's not a fraction and it means something different than a fraction does. So you have to realize, if we're talking about ratios, and you know the concept is on ratios, and you see it written as a fraction, it's not the fraction 4/3, it's the ratio 4 to 3. So you really need to pay attention to the context when you see that. Is it a fraction? Is it a ratio? I will always use one of these two here. Okay. The one time when you will see a ratio in fraction form is when you're talking about something like slope. We're going up 3 over 2, up 3 over to, that's why it's got this fraction form. But again, context. Yes.
Can't you write with a hyphen too, or no?
Not mathematically. They are written like a win-loss record for sports is written as a hyphen. If you go 12-4, that. But again, that's context. You aren't going to see that in the math sense because that's a minus sign, and we don't want to confuse the two. Okay. How about red to green? The ratio of red marbles to green ones. What's the part of the bag that is red? What's the part of the bag that is green? It's questions like these that I expect almost every hand up in the air. How many red? How many green? Maggie? 3 red, 12 green. The ratio is 3 to 12. What is that ratio simplified? 1 to 4. Okay, and how she got that was by dividing 3 by 3 and 12 by 3. Divide by the greatest common factor, and we get 1 to 4. That means that for every 1 red marble, there are 4 green ones. Okay, for every 1 red one, there are 4 green ones. Written 3 ways, with a colon, with the word, and if we're talking about slope, 1 to 4 in fraction form like that. How about blue to green? Blue to green. How many blue? How many green? What are the parts here? Blue to green. Anybody? Yeah. 8 to 12. That in simplest form? Aiden?
Would that be 3/4?
Not 3 to 4,
2/3?
2 to 3. And I hear that you're saying it in fraction verbiage, 2/3. It's very much not that. Okay? It's 2 to 3. It's saying that for every 2 blue ones, there are 3 green marbles. Written 3 ways, 2 to 3 with a colon, 2 to 3 with the word, and if we are talking about something like slope, 2 to 3 rise over run. Okay. How about yellow to red? Yellow to red. So, Yvonne. 6 to 3. In simplest form?
2 to 1.
2 to 1. That means there are twice as many yellow as there are red. For every 2 yellow, we've got 1 red. Written 3 ways with a colon, the word 2, or if we're talking about slope, up to over 1, written like that. This last one here, you got to be thinking carefully here. Red to blue and green. Okay, it's still a 2-part ratio here, and the word 2 is what separates our 2 parts. So I want the part that is red on one side, and then the part that is blue and green on the other side. And maybe be more grammatically correct to say blue or green, because we don't have any marble that's both blue and green. But on one side, we've got the red ones. On the other side, the number of blue and green marbles. So we've got 3 red. And blue and green together, 8 blue, 12 green. Total, we've got 20 blue and green marbles. So this ratio would be 3 to 20. And you can tell, like I said, kind of where that separation point is between the 2 parts with that word 2. That represents our colon, right? Can this be simplified? It can't. Is that okay? Yes. So we can go directly over to 3 ways to write it. 3 to 20 with a colon, 3 to 20 with the word, or in something like slope, up 3 over 20. Up 3 over 20. Have you had these before? Is this kind of ringing a bell, or is this new? I assume you've done something. Yeah, Aiden?
Oh, I was just raising my hand.
That you have had it before? Okay, good. Anything else from things you've heard in the past that I haven't said yet that you just want to bring up or clarify or ask about with regards to ratios? Okay. We've already answered the question, how is a ratio different from a fraction? And we'll do it again here. How is a ratio different from a fraction? How is a ratio different from a fraction? Aiden?
Ratio compares a part to a part, and a fraction compares a part to a whole.
Good. A ratio compares a part to a part, whereas a fraction compares a part to a whole. We have them both because sometimes we want to do different things. We brought up that sports record before of 12-4. As a ratio, wins to losses, 12-4. As a fraction, you'd say you've won 12 out of 16 games. Okay? From a ratio, you can get the whole by adding the two parts together. We can see there are 16 games played total here. You won 12, you lost 4. The fraction, it gives us the whole, that 16, 12 out of 16. We can calculate how much we lost by subtracting. 16 minus 12, we must have lost 4 of the games. I should start doing test scores and ratios, like on a 36-point test. 34 to 2. Questions right, questions wrong. I should do that. How many pages is this objective here? Whoa, 2 pages. Excellent. So it says answer the questions, put your ratios in simplest form. Kind of go in some real life situations here. You are baking a cake and the recipe calls for 32 cups flour and 42 cups sugar. It's a big cake. What is the ratio of flour to sugar? In a previous objective, we've talked about little words or phrases like varies directly. That's important. The word per is important when writing an equation. With ratios, you're looking for that too, right? Because that tells us what we're comparing. We're comparing flour to sugar, and that 2 represents our colon. So once we recognize that, we go back up to the question and say, okay, well, how many cups of flour are we talking about here? 32. How many cups of sugar? 42. Okay, and so there is our ratio. It does say to put it in simplest form. So what would 32 to 42 be in simplest form? What can you divide both of those by? Annika? 16. Oh, you divided by 2. Yes, I thought you were saying you divide by 16. Yeah, divide each of these by 2. And we get the simplest form final answer ratio of 16 to 21. Those of you who do bake have probably dealt with ratios before in something like this. If you're making like a Thanksgiving meal and your recipe for your mashed potatoes serves 2, but you've got to serve 10, right? You've got to increase that recipe by a scale factor of 5. If you don't increase everything by a scale factor of 5, then it's going to taste more salty or less potatoey or whatever it might be, right? But baking, you definitely use ratios often. A pet store is 18 dogs and 48 cats. What is the ratio of dogs to cats? Again, we identify that word 2. That becomes our kind of middle. We see there are 18 dogs, 48 cats, and so our ratio is 18 to 48. What can we divide each of these by to put it in the simplest form here? Greatest common factor of 18 and 48. Divide by 6. And that gives us 3 to 8. Meaning that for every 3 dogs, there are 8 cats. So if we want to purchase... Would it make a difference if you switched it around? If it's asking for the ratio of dogs to cats, then you need to put it in that specific order. Otherwise, if you wrote 48 to 18, that would say that there are 48 dogs for every 18 cats. So yes, your ratio does need to be in the order that it's asking you for. Okay? But anyway, if we wanted to keep this in the same ratio, if we purchase 3 more dogs, then we have to purchase 3 more cats, or 8 more. cats, right, to keep that ratio balanced. A line passes through 2, -8, and 12, 14. What is the ratio of its rise to its run? This is essentially asking to find slope using that slope formula, y2 minus y1 over x2 minus x1. But it draws attention to the fact that one example where ratio is written as a fraction, it's actually a ratio of something. It's comparing the part we rise to the part that we run. Okay, so just a little word on that. You're using the slope formula, y2 minus y1 over x2 minus x1, and that slope is that rare circumstance when we do write a ratio as a fraction. But let's look at a different type of question. Other things we can do with ratios here. The last one on the page says, the boy to girl ratio in a class is 2 to 3. And this is why that order is important. If I tell you the boy to girl ratio in a class is 2 to 3, that means that there are 2 boys for every 3 girls. Okay? The order the ratio is presented is the order the ratio should be written. It doesn't mean there are 5 students in the class, though. Turns out there are 30. How can we use that ratio to calculate the number of boys and the number of girls in the class? For every 2 boys, there are 3 girls. That's what that ratio says. And there are 30 total students. How can we use that to calculate the total number of students, or the number of boys and girls? John?
30 divided by 2 to get 206 boys.
30 divided by 2 to what?
30 divided by 2.
Well, that would give us 15. Does that mean there are 15 boys and 15 girls?
No, but then we do 30 divided by 3.
Okay, so that'd be 10. And 15 plus 10 is 25. Doesn't quite get us to 30. So, but you're thinking the right idea here. We have to divide or multiply by something. Let's start by looking at this ratio of 2 to 3. How many students are represented here in the ratio 2 to 3? 5, right? 2 plus 3 equals 5. We want to get to 30. So what's our scale factor? What do we have to multiply 5 by to get to 30? 6. Right? 5 times 6 equals 30. So what are we going to need to do to the 2 and the 3 to get the total number of boys and the total number of girls if our ratio has a scale factor of 6? Multiply by 6, right? If the total 5 need to be multiplied by 6 to get to the 30 students, then we're going to multiply both 2 and 3 by that same 6 to get 12 and 18. 12 boys, 18 girls. We can easily check this. Does 12 plus 18 equal 30? Yes, it does. If we put 12 to 18 in simplest form, do we get 2 to 3? Yes, we do. Okay? But it's finding this scale factor here that was the key. Right? Let's go to the second. Any questions on this, what I just did here? Okay. Let's look at the second page. It says at halftime of your basketball game, the ratio of your score to your opponent's score is 7 to 4. The total score at halftime is 33. So let's stop here and let's figure out what the score at halftime is. The ratio of your score to your opponent's score is 7 to 4 with 33 total points scored. Just like we did in the last one, who remembers what we do first here? Yvonne? Add 7 and 4 to get the total of our ratio. And then we got to figure out, okay, how do we get to the total of the game or the half? What's our scale factor to get from 11 to 33? 3. So because we multiplied 11 by 3 to get to 33, we also have to multiply both our 7 and our 4 by 3. which gives us a halftime score of 21-12. Of course you're ahead in basketball. You're St. Vincent, for goodness sakes. Right? Does 21 plus 12 equal 33? Yes. If we simplify that, do we get 7-4? Yes. Our scale factor is 3. So then it says, if the same number of points with this same ratio are scored in the second half, what will the final score of the game be? So same ratio, same number of points. What's the final score? 66 is the total, but what's the final score? But you're on the right track because you doubled 33. 42-24. And here's another instance where Aiden asked earlier, can you use a dash? You know, when we list a score of a game, we typically put a dash there, but it's really a ratio of your points to your opponent's points. Okay, 42-24. We just doubled everything. The ratio of bottles of pop to cans of pop in a cooler is 4-3. So bottles of pop to cans of pop is in a ratio of 4-3. There are 20 bottles. How many cans are there? We have a ratio of 4-3. 4 represents the bottles. But this time we aren't given the total, the grand total. We're given the total number of bottles. 20. How can we use that information to determine how many cans there are? Eugene. Sorry? To get 5, right? 5 being that scale factor there, yeah. It all goes down to scale factor here. What do you have to multiply by to get to what's actually going on? If 4 times 5 is 20, then in this ratio, we'll also multiply 3 by 5, and that's going to give us the total number of cans, 15 cans. Okay? So for all of these questions, you have a couple more to do yourself here. Sorry, there is homework. Okay? You had your chance. But you are looking at the ratio, the part to the part, and you'll be using scale factor in some form. Sometimes scale factor is with the grand total, like with the number of kids in the class, number of points in the game. Sometimes that scale factor is just with one of those parts. So reading these questions and understanding what each number refers to is going to be important. Okay? Your homework is to finish the rest of the page. We'll go over it tomorrow. Any questions, final comments, concerns, complaints, comments, congratulations, criticisms? No, you're clearly ready to go. So that is how you math with gusto. Thank you.